Hello there, this is Mr. Bainey, and this lesson is 3.2 Rate of Change and Slope. The standard is 8.f.4, and the essential question, how do you find a rate of change or a slope? And they mention both of them because really they're the same thing. And when we're working in proportional relationships, they end up being the same thing as the constant of proportionality. So they're not always the same thing. Keep that in mind. But when it is proportional, they are. Uh, there's a rate of change definition that's given to you here. It's the ratio of the amount of change in the dependent variable to the amount of change in the independent variable. That's our x and our y. So really, it's dependent variable represents the y. Whoops. The y, and the independent variable represents the x. So it's how much the y changes divided by how much the x changes. So let's look at an example at the bottom. This table here shows the approximate height of a football after it's kicked. You're going to tell whether the rates of change are constant or variable. So we're going to find the rates of change, which means look at the height on the right side. If we go from 0 to 18, that's changing, right? It's changing by 18, and the way we figure that out is we subtract. So we do 18 minus 0, and that gives us a change of 18. So when the height changes, if you look on the left side, how much does the time change at that time? So when the height changes by 18, the time changes by, we take 0.5 minus 0, that gives us 0.5. So that's that change, and the height is that change. So we're going to do 18 divided by 0.5. It's okay to use your calculator here. You end up getting 36 as your rate of change. Okay, so when it changes from 0 seconds to 0.5 seconds and the height changes from 0 to 18 feet, the rate of change is 36. Really what that means is it's changing at 36 feet in 1 second. Okay, because it's only 18 feet in half of a second. So next is from 18 feet to 31 feet. How much does that change? Well, we subtract 31 minus 18 will give us 13. Okay, so that's our change in height. Our change in time from 0.5 to 1.5. So I subtract 1.5 times 0.5 will give me 1. So I'm looking at a change of 13 feet over 1 second, which is a rate of change of 13 when I divide. And lastly, 31 to 26, if I take 26 minus 31. So what's weird here is that I actually get a negative number because it goes down instead of going up. And then from 1.5 seconds to 2 seconds, if I take 2 minus 1.5, that's a change of 0.5. Negative 5 is my change in height, divided by 0.5 is my change in time. I do get a negative number here, it's a negative 10. Okay. And the way we're answering this rate of change being constant or variable is constant means all the rates of change are the same. Variable means all of the rates of change are different. So look at our rates of change that we got. We got 36, 13, negative 10, and that means we have a variable rate of change. Okay, on this explore activity, this has you looking at a graph and finding rate of change. Okay, going to be very, very similar because we can easily put these points into a table and do the same thing. So we're going to look at, if you see these points, 1, 15, 2, 30, 3, 45, and 4, 60. The 1, 2, 3, and 4 x values are the time in hours. And then the 15, 30, 45, and 60 is our distance in miles. So the way we're finding rate of change is how much does the distance change divided by how much the time changes, right? It's the y, change in y over the change in x. So if I'm going from 1 comma 15 to 2 comma 30. So I'm drawing my arrow there on the right side. We're looking at how much does it change from 15 to 30. So I subtract the 30 minus 15, which is 15. The time changes from 1 to 2. So I subtract those and I get 1. So my rate of change here is 15. Okay. The rate of change from 1 hour to 4 hours. So let me erase my arrow on the right side on the graph. And we're going from 1 hour to 4 hours. So look at my arrow. We're going from 60 to 15. Sorry, from 15 to 60. That means that I'm going to subtract 60 minus 15, which is 45. Again, use a calculator if you need to. The change in time, we're going from 1 hour to 4 hours. So that is 4 minus 1, which is 3. So the rate of change is 45 divided by 3, and that is 15. Okay, so remember right above it said from 1 hour to 4 hours. And then part C says find the rate of change from 2 hours to 4 hours. Okay, I'm going to show with another arrow. From 2 hours, it's 2 comma 30, to 4 hours, 4 comma 60. So that means my distance is 30 miles to 60 miles, so it's 60 minus 30. And then the time is 2 hours going to 4 hours, so 4 minus 2. So I get the fraction 30 on top and 2 on the bottom. And when I divide, 30 divided by 2, that's 15. So what do you notice about all of our rates of change? Is this constant? Part D says, recall that the graph of a proportional relationship is a line through the origin. So this is important. It's through the origin. And I'm going to mark it on the graph. There's the origin right there. Explain whether the relationship between Nathan's time and distance is a proportional relationship. So the graph is proportional because it is going through, or you can see that it's starting at the origin. So because it goes through the origin. So on a graph, it's easy to just tell by observation that it is proportional or not. So if you don't have a graph, you have to, do a little arithmetic to figure that out. On the top of the next page, you'll see the slope formula, and this is the same thing that we've been doing, which is looking at the change in y divided by the change in x. This formula actually gives us a more formal way to find slope by just plugging in these numbers. Okay, and then if you look at the graph that's up here, this tells you how to do rise and run, and then find your slope that way. So as you can see in the graph, if the rise is 2 and the run is 3, the slope, let me erase that. The slope would actually be, it's always rise on top and then run on the bottom. So you'll always hear rise over run. Since in the picture, in the graph, the rise is 2, we put that on top. The run is 3, we put that on the bottom. So 2 over 3 would be the slope. And then the example that's on the bottom. So I'm gonna write out the points, the x and y coordinate of these points. This graph shows the rate at which water is leaking from a tank. The slope of the line gives the leaking rate in gallons per minute, and we're going to find the slope of this line. So the first point here is 4, 3. The second point is 8, 6. So I want to know what's the rate of change going from one to the other. So let me show you two different ways. If I start at the 4, 3, start at this point, I want to know how do I get to this other point, but I can't go directly there. I'm gonna do a rise and a run. So I'm gonna rise. Check this out. Keep in mind how much am I rising, and I'm gonna run. How much am I running? Okay, let's try that again. I start here. I'm gonna rise. I'm gonna run. So really, you could do this as long as you know which way you're going and as long as you can count. So there's my rise, and here's my run. It's important which way you're going to. Rise is going up or down. Down would mean negative. And then run is going left or right. And then left would be negative. Yeah, so up would be positive, right would be positive. So the rise ends up being 3, and then the run ends up being 4. Okay, so I'm going to fill in this stuff here on the left side. So let me show you also how to do this with slope formula. So if I'm going from 4, 3 to 8, 6, our slope is our change in y, which is our rise, over the change in x, the run. So to find the rise, it's going from 3 to 6. So that means I'm going to take 6 minus 3. And then for the run, it's the x coordinates. I'm going from 4 to 8. Okay, I'm going to draw the arrow there, from 4 to 8, which means I take 8 minus 4. So when I actually subtract these, 6 minus 3 on top is 3, and 8 minus 4 on the bottom is 4. So look at that. I have 3 over 4 here. And then for my rise is 3, and my run is 4. So this would be 3 over 4 again. So same thing. I get the exact same thing. Whether I use the graph and draw my arrows, or I do the slope formula that I have showing in blue. Okay, and that's it for this lesson. Thank you so much for watching. I hope it was helpful. Have a great day.